All right, picking up where I left off on this piecewise graph. And yeah, there is a little problem here. What the author gave us is the correct answer if the original problem had said 0. The original problem, where was it? If, let's use that color here because they drew it in blue. If it had said 0 and 0. Now, I got these slides from the book. I don't know if I said that before I cut off the video. And the web, I got them from the website, same website you have. So you could see these. You could see the PowerPoint slides. So to match the slide with the author's solution. So basically, if that said 0, it means the change happens when x is 0. And so, okay, that is the correct answer to a different problem, this graph. But what if I wanted to stay with what I'm going to call the left graph all the way up until 1 instead? And then I wanted to use the right graph at 1. How would this change? Well, hopefully it's fairly predictable. Let me do the left graph in blue like they have it. But what I'm going to do is I'm going to take this graph, but I'm going to continue it. And then I'm going to put an open circle because the less than doesn't have the equal to part on it. So just leave it as an open circle. So I'm continuing that graph to that change point. And then I'm picking up this graph, not at 0 like they did here, but I'm picking it up at this point 1, -1. This will not be a filled in circle. And I get that graph. So this was a better image for the question that they originally had. I don't know what happened, why the author's PowerPoint had a graph that wasn't exactly the same as the image. But this is one of the types of problems we'll have. It passes the vertical line test because of that open circle there. So that's kind of an important idea here. And it is an example of a discontinuous graph. When I say discontinuous graph, is there's a gap between the thing. I can't draw this without lifting up my pencil. Didn't mean to erase that much of it. I can't draw this without lifting up my pencil, and that's one of the things we do a lot. We talk about, one more time. Okay. Put it back in. All right. And I just wanted you to see that. So discontinuity or a discontinuous graph, it's a common thing we look for in graphs like this. So sometimes I do have students do this in a face-to-face class where I'll have them draw one of the graphs in one color and the other graph in the other color. So when they do touch, at least I know that they know that we're following a different set of guidelines depending on the values of x. All right. This one will highlight some of that even more so. So this is going to be a function. And just a reminder, when you graph a function, it passes the vertical line test. That's what functions do. So we'll ultimately see a picture of this. And that's where I want to get to. A lot of this other mechanical stuff you should look at, but what's the graph look like? So hopefully they get it right. Yeah, just kidding. I know they do. All right. So remember this one was passes the vertical line test at 2, but there's one graph for less than 2 from -4 to 2. There's another, just a point, when x equals 2, it's 2, so just a single point. And then there's yet another one where they follow, this graph, but only after you get to 2. Now I keep on saying it's a vertical, it's going to pass the vertical line test. Back to the original graph. You don't want to graph the entire function for any of these. You don't want to graph the entire line. You want to graph this line, but you want to stop. Again, that's not an asymptote, but I draw asymptotes the same way. But you want to draw this line just from -4 to 2. So there'd be an endpoint somewhere out here, and it would open circle there. X is 2 when X is 2. So just a dot right there. And then this is a parabola. So the whole graph would look like this, right? I don't want to graph the whole thing. I just want to pick it up and draw the parabola. All right, so that was my very hand-drawn. Didn't even really mark the x, the y-axis. That was my very quick drawing of that. And that's basically what you want to, how I want you to be able to see it. I want you to be able to see it as just one graph, but it's stopped, and then you pick up with another graph on the other side of that line. After you have the image, they'll ask you what's the range. Okay, let's look at that. So the range is the minimum y value to the maximum y value. Well, minimum y value is -2, but it goes up to infinity. So the y values have a range. X values also have a range. I think that you can tell from the image. Minimum x value is -4. Maximum x value, well, it just keeps on going. So all of that. Trying to see where they ask that. I'm just saying they probably ask what the domain is, because that's what they do. Domain of each equation, looking for that actual step. There we go. Domain x is greater than or equal to -4. Just so you know, that's a very common question. I knew I was going to find it. That's how common it was. All right, so back to the original function. When you see things like this without the markup, those are piecewise functions. And let me just add one more thing about this. So one of your favorite functions, well, I don't know if it's your favorite function, but one function, probably the first function you ever studied, not square root, but absolute value. The absolute value function can be thought of as a piecewise function because there are two separate sets of rules for absolute value. What are they? Well, the absolute value of x is just equal to x. Let's write down here, if x is greater than 0. All right, greater than or equal to 0. And it's equal to minus x if x is less than 0. Now, this might seem counterintuitive, but I'm saying it's equal to minus x because I want to take the negative number and change its sign. So the way I do that is I multiply by a minus sign. So absolute value can be thought of as a piecewise defined function. And it's certainly a function you've been familiar with for a long time. So it's something that you should know, that piecewise defined functions aren't this obscure thing that the author's just concocting to create weird graphs like that. You know, every once in a while we come across a real thing that we've done in our past that actually does have something to do with the more advanced topics we talk about. But all right, that is the continuation of the first part of this video, but that concludes the section 3.5.